This video is about constructing and utilizing the properties of a perpendicular bisector circumcenter and an angle bisector incenter. So the three perpendicular bisectors in a triangle meet at a point called a circumcenter, which is equidistant from the vertices of the triangle, and the circle is drawn outside the circle. Outside the triangle. So we see this circle and it's intersecting at each vertice of the triangle. So these three segments would be congruent to each other. The three angle bisectors in a triangle meet at a point called the incenter, which is equidistant from the side of the triangles, and the center of the circle is drawn inside the circle. So this time we have our circle and we have the three segments going from the center to the side of the triangle, which would be congruent. So in number one, we have that D is a circumcenter. So I'm going to draw a circle around. It doesn't have to be a perfect circle, especially if there's not that much room. So we know that A, B, and C are on the circle. So AD, BD, and CD are congruent. So we have that CD is 5x plus 30. We have ED, which was not one of the segments we marked, so we're going to cross it out because that's not something we're going to use. And AD is 15x minus 30. So these segments are congruent. 15x minus 30 equals 5x plus 30. We can subtract 5x from both sides. 10x minus 30 equals 30. We can add 30 to both sides. 10x equals 60. We can divide, so x is 6. Then we need to find the measure of BD. Well, BD is going to have the same measure as AD and CD, so we're going to pick one of those segments, and we're going to put 6 in for x. So I'm going to use CD, 5 times 6 plus 30, so that will get us a length of 60 for BD. In number 2, D is an incenter, which means that the circle is going to be inside our triangle. And it's going to be equidistant to the sides. So RD, SD, and TD are congruent. So we have ED, which we're not going to use because that's not one of the segments in the circle. We have RD is 8x plus 12, and SD is 12x minus 12. So those are going to be congruent. 8x plus 12 is equal to 12x minus 12. So when we solve, we get 4x equals 24. When we divide, x is 6. So to find TD, we know that TD is going to have the same length as RD and SD. So I'm going to pick one of those. 8 times 6 plus 12 is going to get us a length of 60. In number 3, D is a circumcenter, which means that the circle is going to go around our triangle. So that means AD, BD, and CD are congruent. We're given that AD is 6x plus 18. FD is not one of the segments that we know is congruent, and BD is 9x minus 27. We want to find CD. So first we know that these two segments are congruent, so 6x plus 18 equals 9x minus 27. So we get 18 equals 3x minus 27. We can add 27 to both sides. 45 equals 3x. When we divide by 3, x is 15. So then to find CD, we are going to pick one of the given segments, AD or BD. So we're going to say that CD is equal to 6 times 15 plus 18. Well, 6 times 15 is 90 plus 18 gets us 108. In number 4, D is an incenter. So we want to solve for x and find GB. So if it's an incenter, GD. So if it's an incenter, it's going around inside the circle. So ED, FD, and GD are congruent. 2x plus 24. AD we're not going to use. And ED is 6x minus 12. So we can set those equals. 6x minus 12 is equal to 4x plus 24. Oops, sorry, 2x plus 24. So as we solve, 4x minus 12 is equal to 24. We can add 12 to both sides. 4x equals 36. When we divide, x is 9. And then to find the length of GD, we need to plug into one of those segments. So we're going to say GD is equal to 2 times 9 plus 24, which gets us 42. In number 5, we know that D is a circumcenter, so it is going around the outside of the triangle. So we have that AD, BD, and CD are congruent. So we're not going to use the ED and the GD and the DG. We would have 2x minus 12 is equal to 5x minus 22. We can subtract 2x, negative 12, negative 10. Is equal to 3x minus 22. We can add 22 to both sides. 12 is equal to 3x. When we divide, x is 4. In number 6, D is the incenter. So we can draw a circle around our parts. These 3 segments are congruent. So we're going to use JD and LD. So 15 equals 4x plus 3. We can subtract 3. 12 equals 4x. When we divide, x is 3. In number 7, given that G is an incenter, complete the following statement. So because G is a incenter, we know, or a circumcenter, we know that it is formed by perpendicular bisectors. So when we go to mark our triangle, we know that the 3 segments that are congruent are going from the center to the vertice. We also know, because it is a perpendicular bisector, that these lines are perpendicular to the sides and they bisect the sides. So this will help us complete the following statements. So CD, which is a side of the triangle, is congruent to AD because D is the bisector for the segment. GE has no marking, so it's not going to be congruent to anything. AG is going to be congruent to BG and CG because of the circumcenter. They're all equidistant from that point to the vertice. Angle ABD has no marking, so it's congruent to nothing. And the measure of angle BDC, well, BDC is this angle right here, and it's a right angle, so it is 90 degrees. In number 8, G is an incenter, which means it's formed by the angle bisectors. So when we label our triangle, we know that the circle is inside the triangle. So these 3 segments are congruent. A property that we'll learn later on is that these are going to be right angles because those lines are intersecting the side and the angles are bisected. So CF has no markings, it's not congruent to anything. EG is congruent to DG and FG because they're all from the center to the side. BG has no marking, so it's not congruent to anything. Angle CAF at the top is going to be congruent to angle BAF. And the measurement of AFC is going to be 90 degrees because there is a right angle there.